Hello, my name is Kishore Kumar. I'm the founder of KISH-CAT classes. This is the second video of basic reminder theorem. In the first video, I've clearly explained you all the concepts. In this video, I'm going to solve 11 CAT questions which appeared from 1990 to 2014. That is the last 25 years of CAT. I suggest you to watch the concept video and also I suggest you to solve all the 11 questions. You can get the worksheet from Facebook page of KISH-CAT classes. Now, before we solve the 11 questions, let me tell you what we are going to do in this video. That is, like, we're going to solve 11 questions, and all the 11 questions are appeared on CAT 1990 to 2014. So the concept that I covered in the last video is a plus b by c remainder is simply a by c remainder plus b by c remainder, and also a into b by c remainder is a by c remainder into b by c remainder. And also I've solved a power n plus or minus b power n divided by a minus b. What could be the remainder? When n is even and also when n is odd. So based on the basic remainder theorem, we have got 33 questions appeared in common admission test. So let's go through question number 1. If x is a positive integer such that 2x plus 12 is perfectly divisible by x, then the number of possible values of x. This must be very simple. So let's solve. So 2x plus 12 divided by x, the remainder is 0, and we need to find the number of possible values for x. This must be very simple. So as per skill set 1, this is 2x by x remainder plus 12 by x remainder. Now this remainder is obviously 0 and this remainder must be 0. If 12 by x remainder must be 0, we can easily check the possible values for x. So that is 12 by x, x takes 1, 2, 3, 4, 6 and 12. That is, x can take 6 different values. That's very easy. But what happens instead of 12 if we have a very big number? A number like 65 or a very big number, a 3-digit number. Can we manually identify the divisors? That takes a lot of time, even if we have the ability. Then how can we approach? Let's check what is this 1, 2, 3, 4, 5, 6. Now 1, 2, 3, 4, 5, 6. So 1 multiple is 12, 2 multiple is 12, 3 multiple 4, 6. For every number, 12 is a multiple of these divisors. In return, all these divisors are factors of 12. So if you can identify the factors of 12, that is very, very easy. Now if you want to identify the factors of 12, that's very easy. You just need to write this number as a power p into b power q into c power r and so on. Whereas a, b, c are prime factors and p, q are natural numbers. Now for this one, 12, we can write this as 2 square into 3 power 1. So the number of factors would be 2 plus 1 into 1 plus 1. That is, if you want to know, that is p plus 1 into q plus 1 plus r plus 1 and so on. So here this is 3 into 2, that is 6. So that's very easy. It's completely based on factors. Let's solve next question. Let k be a positive integer such that k plus 4 is divisible by 7. Then the smallest integer n greater than 2 such that k plus 2n is divisible by 7 equals to. So we just need to find k, the value of k, and it must be greater than 2. Now first we have a number that is given in variables, that is k plus 4 is divisible by 7. So let's solve this question. If k plus 4 is divisible by 7 and when the remainder is 0, we can easily say that k by 7 remainder depends on k, and 4 by 7 remainder we can easily find that is 4. So k by 7 remainder depends on k, and 4 by 7 remainder is 4, and whereas the total remainder for the whole thing is 0. In such a case, this must be 3. So k by 7 remainder must be 3. Then only we can say that the whole remainder is 0. So we can simply say that the minimum value that k can take is 3, and k can take 10, 17, 24 and so on, whereas these numbers are of the format 3 plus 7x. So k is a number which is of the format 3 plus 7x. Now, if a number is given in the format k plus 2n and that is also divisible by 7 and also n is greater than 2, so we need to find n. So here what we need to do is like k plus 2n divided by 7, the remainder given as 0, and n is also greater than 2. So how can we do is like we know that k is of the format 3 plus 7x, and we have a number like 2n divided by 7. So that is 3 by 7 remainder plus 7x by 7 remainder plus 2n by 7 remainder, and sum of the remainders must be equal to 0. We know that 3 by 7 remainder is 3. That's very simple. We know 7x by 7 remainder is 0, and here we can say that 2 by 7 remainder into n by 7 remainder, and we know that n is greater than 2. In such a case, this number is 0 plus 3 plus 0 plus this is 2 into n by 7 remainder. That is like 3 plus some value here. We need to get 2 into n by 7. Now 2 into n by 7 must be 4. Then only we will get the remainder as 0. So in such a case, n need to be either 2 or more than 2, since a condition is given that n must be greater than 2. So n can be 2 or 2 plus 7, that is 9, or 9 plus 7, that is 16, and so on. That is, n is of the format 2 plus 9y. It's a very simple one. So in place of y, if we take 0, then n becomes 2. In place of y, if we take 1, no, this is not 9y, that is 7y. 2 plus 7y. So since n is greater than 2, in such a case y cannot be 0, y must be 1. If y is 1, the next minimum value of n happens to be 9. So that's simple. What we have done is quite simple. So we try to find the format of k. Once we try to find the format of k, then what we have done is like we try to find the format of n. N is of the form, so k is of the form 3 plus 7x, n is of the form 2 plus 7y. So we have substituted both of them and we found value of n based on the condition. Let's solve question number 3. If n is a positive integer, then n cube minus n is divisible by, or n cube minus n is divisible. Now when you look at all the numbers, all the answer options, it says that always by 12, never by 12, always by 6, never by 6. Now if you check this one, answer option A and then answer option C, when you observe them, one says that always by 12, one says that always by 6. Well, in fact, if a number is divisible by 12 actually, then it is obviously divisible by 6. So we just need to understand the answer options also closely. Well, I'm not going to use any one of the answer options to find. That's it. It must be very simple. So n cube minus n, we can write it as n cube minus n is like n into n square minus 1. Well, this is nothing but n into n square minus 1 square. This is nothing but n into n plus 1 into n minus 1. That is n minus 1 into n plus 1. Look at this. These numbers, n minus 1, n plus 1. Well, there are 3 consecutive natural numbers. And we know that n is a positive integer. So if 3 consecutive natural numbers are multiplied, Well, we can easily say that one of them is even, one of them is odd. The two of them can be even, one can be odd, or two can be even, and two can be odd, and one can be even. So here, what we can do is, if these are three consecutive natural numbers, the minimum number happens when we take these are first three natural numbers, that is 1, 2, 3. So 1 into 2 into 3, that is 6. Now we can always take the other numbers also. We can take 4 into 5 into 6. We can take 10 into 11 into 12. We can take some other numbers as well. But in such a case, what we get is like we'll get a very big numbers. There's a 2-digit, 3-digit, 5-digit, 10-digit numbers. However, what we supposed to know is we need to know the minimum value. If n can be any positive integer, that is the clue here. Any positive integer. This is like variable based question. You have the flexibility of taking any number in place of n. Now, whenever you come across a question which is of the form of variables, do remember that you have the liberty of substituting any natural number or any number based on the conditions given here. So that's why this is like a variable to numbers format question. So whenever you come across a variables to number format question, try to check the condition whether you can take any value in place of variable. And also do remember, if there is any condition given for n also, that is like n greater than some number. So here n is a positive number, so we have the flexibility of choosing n as a minimum value. Let's solve next question. A positive integer is said to be a prime number if it is not divisible by any positive integer other than itself and 1. Let p be a prime number greater than 5, then p square minus 1. Well, it's quite simple. P square minus 1, it's a flexible question. We have the liberty of choosing any number for p. Since it's given, there is a condition given, that is p is a prime and it is also greater than 5. Now, do not try to check any answer options. Since you have the liberty of choosing any prime number, I suggest you to choose the least prime number. The advantage is, once we choose a least prime number, the p square minus 1 would be a very limited 2-digit or maximum of 3-digit number. Now, when we have a limited 2-digit number, it would be very easy to find either the factors or the multiples of it. Now, p square minus 1 can be written as p square minus 1 square, that is nothing but p plus 1 into p minus 1. P is a prime number. Any prime number, that is any prime number excluding 2 is an odd number. So p is an odd number. Now odd number plus 1 is an even, as well as odd number minus 1 is also an even number. So these are two consecutive even numbers. So the product is also an even number. Now when you check the answer options indicated that it's never divisible by 4, it's divisible by 6, and it's not divisible by 12, or it's not divisible by 24, or it's always divisible by 24 kind of ones. Now how can you approach this one is, you should have some idea about the formats of the prime numbers. Except the first two prime numbers, that is first prime number is 2 and the second one 3, all the remaining prime numbers, that is like 5, 7, 11, 13, 19, 23, 29, all the prime numbers, these are of the format 6k plus 1 or 6k minus 1 format. When we substitute 6k plus 1 in place of p, how it happens is, this is going to be 6k plus 2 into 6k. So obviously the whole thing is now 36k square plus 12k. So if we take out k common, this is going to be 36k plus 12. Now k has to be at least 1. K cannot be 0. If k is 0, the number is going to be 1, which is not prime. Now if we substitute 1 in place of k, the whole number is going to be k into 48. It means that it's a multiple of 48. If we substitute 2 in place of k, This is going to be 2 times 84. So that's going to be 168. So the minimum number is 48 and the next number is 168. Now, all the factors of 168 might not be the factors of 48. That is why I suggested you to consider the least number. Now, all the factors of 28 are very important. So the factors of 28 is very easy. So we know that we should not identify the factors of 48 manually. So 48 is 2 power 4 into 3 power 1. So now all the factors, that's very easy. So check the answer options now. Now answer option A says that it's never divisible by 6. That is untrue. It's always divisible by 6. Answer option B says that always divisible by 6 and may or may not be divisible by 12. Well, it is definitely divisible by 12. That is 3 into 2 power 2 is 12. Answer option C says that always divisible by 12 and may or may not divisible by 24. That is also untrue because 2 cube into 3 is 24. Now it says that answer option D says that always divisible by 24. That is correct. Well, we know that it's divisible by 6. We know that it's divisible by 12. We know that it's divisible by 24 and 48 also. Since answer option A and B, C are incorrect, we can, without checking answer option D, we can directly mark it. Since we are learning, so no need to just ignore 3 answer options. Let's solve question number 5. If n is any odd number greater than 1, then n into n square minus 1. Look at this one. Again, this is a very variable based question, very simple one. N is any odd number. So the condition is here odd number greater than 1. So n into n square minus 1. So n into n square minus 1 can be written as n into n plus 1 into n minus 1. So that is n minus 1 is the first term, second term is n, third one is n plus 1. So these are 3 consecutive terms, 3 consecutive numbers, not terms, 3 consecutive numbers. Now the 3 consecutive numbers is very simple. If we know that these are the first 3 consecutive numbers, then we can say 1 into 2 into 3, that is 6. So every 3 consecutive numbers must be a multiple of 6. However, we have got a condition here. The condition is n is odd is given and also it is greater than 1. So n must be a minimum value of 3. If n is 3 here, then the whole thing is 2 into 3 into 4. That's going to be 24. Now, when we take the minimum value for n, we get a minimum number. So all the factors of that minimum number should divide any value of n. So even if we take any bigger value of n, all those numbers, all the outcomes of n minus 1 into n plus 1 should be multiples of the factors of 24. Now check the answer options. It's divisible by 96, always. It says that it's always. Now it's not always. When we take the minimum value for n, we cannot say that it's 96. Same is the case with answer option B. Answer option C is divisible by 24. So that's the truth. No need to check some other value in place of n. Now we solve question number 6. The remainder obtained when a prime number greater than 6 is divided by 6 is, again it's just a simple prime number, but it's greater than 6. So a prime number greater than 6. All the prime numbers except the first 2 prime numbers are of the format 6k plus 1. So that is prime numbers greater than or equal to 5. That are the format either 6k plus 1 or minus 1, that is 6k plus or minus 1. Now when we divide 6k plus or minus 1 a number, then obviously If we take the 6k plus 1 by 6, that is nothing but 6k by 6 remainder plus 1 by 6 remainder. So 6k by 6 remainder is 0, 1 by 6 is 1, so that is 1. In the other case, if we take 6k minus 1 by 6 remainder, that is 6k by 6 remainder minus 1 by 6 remainder, so that is 0 and then minus 1, so the remainder is minus 1. The remainder can't be a negative number, so whenever we come across the remainder as a negative remainder, then we just need to add divisor to it to get the original remainder. So since the divisor is 6 here, minus 1 plus 6 is going to be 5. So the remainder should be 1 or 5. It depends on the number format. So always remember, any prime number excluding the first two prime numbers or of the format, or each of the format 6k plus 1 or 6k minus 1. Let's solve question number 7. If n is an integer, how many values of n will give an integral value of some expression is given. So n is an integer, any integer, that's the best one. Now the expression is 16n whole square, 16n power 2 plus 7n plus 6 by n. This must be very simple. The numerator is of the form a plus b plus c divided by n, so that is a by n remainder plus b by n plus c by n, so that is individual remainders. So there is 16n square by n remainder plus 7n by n remainder plus 6 by n remainder. Now this remainder is 0, so this remainder is 0. Now this remainder depends on n. Now since we want an integral value, we cannot take any number in place of n. To get an integral value, that is the remainder must be an integer, we must take in place of n the factors of 6, or you can, since 6 is a very small number, we can check manually. In place of n, if you take 1, the remainder is going to be 0. In place of 2, the remainder is going to be 0. In place of 3, remainder 6 also. Or we just need to check the factors of 6. Factors of 6 equal to 2 power 1 into 3 power 1. So that is of the format a power p into b power q. So the number of factors must be p power 1 into p plus 1 into q plus 1. That is 2 into 2 here. That is 4. So these are 4. How many values can I take? It's a very simple one. Let's move on to solve the next question. A certain number, when divided by 899, leaves a remainder 63. Find the remainder when the same number is divided by 29. This is a very simple question. We have no idea about the number, certain number, that is n. So if the same number is divided by 899, the remainder obtained is 63. Now if the remainder obtained is 63, well, n could be 63 itself. If n is a number which is less than 899, so the remainder must be in the number itself. So here we can directly say that n is 63. The minimum number is n could be 63. Well, what happens if we have a number which is greater than 899? So if a number which is definitely greater than 899 should be of the format 899 plus 63. That is the case, we get the remainder 63. So in such a case we can say n equal to remainder plus divisor into some value, that is k. Now the remainder we are getting is 63 divided by 899k. So if k equal to 0, then we get a minimum number. K equal to 1, we get the next number. So it means that n is of the format 899k plus 63. Now if the same number, that is 8999k plus 63 divided by 29, we need to find the remainder. We can find the individual remainder, that is 899k by 29 remainder plus 63 by 29 remainder. Now this remainder is 0. 899 is a multiple of 29, that is 31 29s, and the 63 by 29 remainder is 5. So the total remainder, final remainder is 5. In fact, we need not find the format of n. We can directly take 63 by 29 as well. So that is 5. Let's have next question. If m and n are integers divisible by 5, which of the following is not necessarily true? Do remember, it is not necessarily. Yeah, m and n are integers of divisible by 5. So if two numbers, that is m divisible by 5, the remainder as well as n divisible by 5, if the remainder is 0, then m and n must be multiples of 5. So in such a case, we can say m and n are of the format 5x and then 5y. We have checked the answer options, and then we need to identify the answer options which is not necessarily true. Now here m and n, that is 5x minus 5y divided by 5, that is 5 times of x minus y by 5. So that's obviously, it's always, in every case of x and y, it's always divisible by 5. So this is answer option A, and this is answer option A. Let's take answer option B. So that is 5x whole square minus 5y whole square divided by 25. So that's obviously 25x square minus 25y square divided by 25. That's very simple. It's divisible. That is 25 times of x square minus y square divided by 25. So the remainder is 0. So this is always true. Now check answer option C. It's 5x plus 5y divided by 10. So that is 5 times of x plus y divided by 10. Now the remainder. So 5 times of x plus y. If x plus y is an even number, then it is a multiple of 10. If x plus y is an odd number, then we get a remainder 5. In such a case, we cannot directly say that x plus y is even. If x plus y is even, we know that 5 into even number is a multiple of 10. This is not the case. X plus y could be odd. Not that x plus y is always even. So in such a case, we can say that C is not necessarily true. It can be true in some cases. Let's move to question number 10. N equal to 1421 into 1423 into 1425. What's the remainder when n is divisible by 12? This is the very simple number. Once you have no idea about how to solve this number, the next immediate step should be to find the number, that is 1421 into 1423. So you need to do it manually. Again, the result must be multiplied by 1425 to get a bigger number, and then we can divide by 12 manually. But that takes a lot of time, hell a lot of time. The time is the most crucial thing in any competitive examination, and CAT goes in the similar lines. In fact, this is the most important examination for you right now. Now, what can you do is, I've explained you in the concept video that A into B into C divided by n remainder is simply, it's A by n remainder into B by n remainder into C by n remainder. That is individual reminders. Now we cannot directly take that it's going to be A into B into C. Then in such a case, A into B into C could be divided by n cube. But do remember, we can really apply this one. It saves a lot of time, and it's a very flexible one. It is not a shortcut, absolutely. So what we can do is like it's 1421 divided by 12 remainder. So once we identify that 1421 divided by 12 remainder is very simple. That is 12 ones are 12 and then carry over is 2, 22. Again 12 ones are 12, carry over is 10, 1 at 1. 12 eights are 96, then it's going to be 5. If 1421 remainder is going to be 5, then the other reminders are going to be 5, 7, 9. That's very easy. 35 into 9 by 12 remainder. Now we need not find how much is 5 into 7 into 9. Now 35 by 12 remainder, we can say is going to be minus 1 into 9 by 12 remainder is 9. So minus 1 into 9 is going to be minus 9. Since we cannot get a negative remainder, in this case it's going to be minus 9 plus divisor 12, that is going to be 3. So we can directly say that the remainder is 3. Let's solve the final question. What is the sum of all the 2-digit numbers that give a remainder of 3 when they are divided by 7? So that is a 2-digit numbers, a specific one, it's a fixed question. All the 2-digit numbers we need to consider. Now n divided by 7, the remainder is equal to 3. Should we really identify 2-digit number? No, it's not, need not. N divided by 7, the remainder is 3. Now, if the remainder is 3, n is of the format divisor into constant plus 3. Absolutely. Now, if k equal to 0, then the remainder becomes 3. So, k has to be a minimum 1. If k equal to 1, then the number is going to be 10. Tell me what could be the maximum value that we can take in place of k? 14? But 14 sevens are 98 plus 3, that becomes 101. So we can take a maximum is 13. So if k equal to 13, then we can say it's 94. Now 10 is the first 2-digit number and 94 is the final 2-digit number. Then what can we do here is, so since k equal to 1 to 13, it means that k can take 13 different values. It means that there are 13 different terms. All of them are of the format 7k plus 3. Now, instead of trying to find 10 and then next value is 17, next value is 24, we can say the first term 10 plus last term 94 divided by 2 is the average. This is the average of first term plus last term into number of terms. No need to find every single term. In fact, all the numbers are in arithmetic progression and we can easily find sum of 13 terms of an arithmetic progression quite easily. Or else you can directly say that first term plus last term divided by 2 is the average of the terms into the number of terms. That's going to be 104 by 2 into 13. That's going to be 52 into 13. It's very simple. 676. Look, we have solved 11 questions. Not all of them are difficult, but some of them will definitely teach you a very good concept. To solve 11 questions, we don't really need a good understanding of every single concept or a good understanding of basic remainder theorem. Since the basic remainder theorem is a very simple one, you must be focusing on the application part of it. Like some of the questions, out of 11 questions, almost more than 50% of the questions were completely focused on application of reminders theorem. You just need how to apply it rather than you should have a very sound knowledge about the theorem. Now, these 11 questions are taken from 1990 to 2014 CAT. Since the level of difficulty of all the 11 questions are very easy, we don't have, that is why after 2003 actual test, because there were two tests in 2003, one is actual and then because the the previous test which got leaked, they had to conduct one more test. Now after 2003, we don't have any EG questions coming from basic Riemann theorem of numbers. Numbers itself has got 8-9 different concepts. How can they give one difficult question on every single concept? Why we had no question after 2003 is quite simple. Every paper after 2003 had a very limited number of questions. The minimum was 21, the maximum was 35 questions. So that is why, if at all if there were difficult questions, the difficult questions might have come from some other concepts of numbers or from some other chapters. Or else we might have one or two difficult questions. So we will solve all those difficult questions in the next video. Now, let's observe what is the next video. So in the next video, before you solve original CAT questions, the next video is related to again the basic remainder theorem. However, all the questions in the next video is all about just divisibility rules. So in the next some videos, I'm going to teach you divisibility rules, that is like numbers of the format 2 power x or 5 power x and 10 power x, divisors 3 and 11, or divisor 11, and then divisor 7, 13, 37. And the next one is the important ones are like the divisor which are of the format 10 power x minus 1 or plus 1. Watch all those videos, learn all of them, learn all those concepts, try to understand all of them, and then come back and then solve the original CAT questions. Thank you.